Now we're going to look at law of exponent subtraction. Let's say we have the expression a to the power of m divided by a to the power of n. What we can do is we can subtract exponents. If m is greater than n, then that's going to be a to the m minus n. If m is equal to n, then that's going to be just 1. I'm going to show you why, okay? If n is greater than m, then that's going to be 1 over n minus m. Greater number minus smaller number. Okay? Let's look at concept check problems. We have a to the power of 5 divided by a to the power of 3. That is equal to a to the power of 5 divided by a to the power of 3. So that is equal to a to the power of 5. That means 5 a's are multiplied together. 3, 4, 5, right? A cube, 3 a's are multiplied together, right? So 3 a's from numerator, 3 a's from denominator will be cancelled out. So what we have left is a times a squared, right? So what we can do is we can just subtract 3 from 5. We can write this a squared as a to the 5 minus 3, right? So a to the 5 divided by a to the 3, that's going to be a to the 5 minus 3. Does that make sense? Okay, number 2, we have a cube divided by a cube, right? So that's going to be equal to a cube divided by a cube. A cube, 3 a's are multiplied together. A cube, 3 a's are multiplied together, right? So all of the 3's in the numerator and denominator will be cancelled out. So that's going to be just equal to 1, right? Which means when we subtract this exponent from this, and if that is equal to 0, then our answer is just 1, right? So that's equal to a 3 minus 3, which is equal to a to the 0. So if our exponent is equal to 0, that's 1. Make sense? Okay, number 3. Number 3 is equal to a cube divided by a to the power of 5. That's a times a times a. This one a times a times a. 4, 5. 5 a's are multiplied together. So 3 a's from numerator and denominator will be cancelled out, right? So that is equal to 1 over a times a squared, right? Okay, so when this number is greater than this, we have to have fraction like this, and this number is greater number minus a smaller number, which is 5, 1 over a to the 5 minus 3, right? Or we can simplify this expression this way. A cubed divided by a to the 5, that's going to be, let's just write 3 minus 5. Okay? Always the left number minus the number on the right. Okay, 3 minus 5. That's going to be a to the 3 minus 5. That's a negative 2, right? So if we have a negative exponent, then what we can do is eliminate negative and write a square in denominator like this. Okay, this is another way to simplify this. All right. Example 3. The question is to simplify the expression. For number 1, we have a to the 4 divided by a squared. So what we can do is we can just subtract 2 from 4, right? If this number is less than this number, that's going to be just 4 minus 2, like that. So that's a square, right? Okay, number 2. We have a parenthesis. So let's solve the parenthesis first. 3 times 4, that's a to the 12. 6 times 2, that's a to the 12, right? Okay, if we have same exponent, then that's just going to be equal to 1, right? Or we can write a to the subtract 12 from 12. So that's a to the power of 0, and that is equal to 1, right? Number 3, we have b to the power of 5 divided by b squared n to the power of 4, right? So that's going to be equal to, let's solve the parenthesis first. b to the power of 5 divided by 2 times 4, that's going to be b to the power of 8. This time, this number is greater than this, right? So that's going to be equal to 1 over b to the this number minus this number, 8 minus 5, right? So that's going to be equal to 1 over b cubed. Or we can simplify this expression as, just subtract 8 from 5, b to the 5 minus 8. Always subtract the number on the right number on the right side from left side. 5 minus 8, like that. Then that will give us b to the negative 3, right? And if we have a negative exponent, what we can do is eliminate negative, write b cubed in denominator like this, right? Okay, number 4. Number 4 is equal to, here, same base. So this number is greater. That's going to be b to the 4 minus 2. And we have divided by b to the 5, right? So that's going to be b squared divided by b to the power of 5. This time, this number is greater, right? So that's going to be 1 over b to the 5 minus 2, which is equal to 1 over b cubed, right? Or another way, we can simplify this way. They're all base b, right? Same basis. So what we can do is we can just write base b, all divisions. So 4 minus 2 minus 5. So that's going to be equal to b to the 4 minus 2, that's 2. 2 minus 5, that's negative 3, right? So that's a negative 3. Oh, we have a negative exponent. Eliminate that and write that expression in denominator. Then we will have the same answer, right? The question is to simplify the expression. Let's say we have a to the 4 divided by a squared. In fraction form, that's a to the 4 over a square, right? So that is equal to a to the 4 means 4 a's are multiplied together times a, and a squared means a times a. So 2a's from numerator and denominator will be cancelled out. So we have a times a, which is equal to a squared, right? So when we have division like this with the same base, what we can do is we can just subtract exponents, a to the 4 minus 2. And this one gives us our answer, a squared, right? Let's say we have a squared divided by a squared. That's a square over a square, right? So we have a times a here, denominator a times a. So both a's from numerator and denominator will be cancelled out. So that is equal to 1 over 1, which is equal to just 1, right? Remember, when we have division, we can just subtract exponents, right? So that's going to be a to the 2 minus 2. So that is equal to a to the 0, right? So we know that a to the 0 is equal to 1, right? Okay, let's say we have a squared divided by a to the 4 this time. In fraction form, that's a square over a to the 4. So that's a times a over, we have a times a times a times a. Again, 2a's from numerator and denominator will be cancelled out. So we have numerator is just 1, denominator a times a squared, right? Remember, when we have division, what we can do is we can subtract exponents, right? So that's a to the 2 minus 4. So that is equal to a to the negative 2, right? And this one is equal to this, which means if we have a negative in our exponents, what we can do is we can just eliminate negative and write a squared in denominator like this. So a to the negative 2 is equal to 1 over a squared, right? So now let's try number 1. Number 1, we have a to the 6 divided by a cube. So a 6 minus 3. So that is equal to a to the power of 3. Number 2, a to the 7 divided by, 2 times 2, right? If we have a parenthesis, we have to multiply these two numbers. So that's going to be a to the 4. So a to the 7 minus 4, that is equal to a to the power of 3. Number 3, we have b to the power of 6 to the power of 2, right? So multiply these two. So that's going to be b to the 12 divided by 4 times 3, b to the 12. So that is equal to b to the 12 minus 12, which is equal to b to the 0. b to the 0, that is equal to 1, right? Number 4, b to the 5 divided by 2 times 2, right? b to the 4 divided by 3 times 4, that's 12, b to the 12. Now, b to the 5 divided by b to the 4, same base, we subtract exponents. Same base, it's a divided by again, division again, right? Subtract exponent, right? So that's going to be b to the 5 minus 4, 1. 1 minus 12, that's negative 11, right? So negative 11. So that is equal to, whenever we have negative in our exponents, write b to the 11 in denominator, right?